welcome to High Tech Study Plus. We are back with another video for class 11th, motion in a straight line. In our previous videos, we have already discussed about the derivation of the kinematic equations of motion. If you haven't watched our previous 3 videos, then do give it a look and you can find it out in the class 11th physics playlist. So let us begin. First topic of the day is free fall. When do we say that the body has a free fall? When the body is released near the surface of Earth, it is accelerated downwards. So it is accelerated downwards because of gravity. So the magnitude of acceleration due to gravity, as we already know, is represented by g, small g, acceleration due to gravity. If air resistance is neglected, then the object is said to have a free fall. Air resistance is neglected, then the object is said to have a free fall. And it is a case of motion with uniform acceleration because the value of g is constant. As the object is released from rest, let us say the object was here and it is released and it is coming towards the surface of the Earth. Initial velocity will be 0. The second equation of motion can be written as y, which is equal to v0t plus half at square. As the body is falling downwards, the acceleration will be negative. So we can replace a by minus t. So it implies that y is equal to v0t minus half gt square, but we know that v0 is equal to 0, so v0t will also be equal to 0. This implies that y is equal to minus half gt square. The value of g is taken to be 9.8 meter per second square, so it is equal to minus half 9.8 into t square, which is equal to minus 4.9 t square. The graph of y with t can be represented as this because it varies with t square. Now the first equation of motion is given by v is equal to v0 plus at. Here also we will be doing the same thing. We will be replacing a by minus g and v0 by 0. So this is 0. This implies that v is equal to minus gt, or this implies that v is equal to minus 9.8 t. So the graph of v and t can be represented as this, since v is directly proportional to t. Now the third equation of motion is given by v square is equal to v0 square plus 2ay. We will be doing the same thing here. Replace a by minus g, this term becomes 0. This implies that v square is equal to minus 2gy, or this implies that v square is equal to minus 2 into 9.8 y, which is equal to minus 19.6 y. This implies that v square is equal to minus 19.6 y. This will be our third equation of motion. Now since acceleration a is taken to be 9.8 meter per second square everywhere, so the AT graph of this body will be given by this. Here is 9.8. This is all about free fall of a body. Now let us discuss about the stopping distance of vehicles. What is this stopping distance? The distance a vehicle travels before stopping after brakes are applied. Suppose body is moving in this direction. It is here. Now it is moving forward. It applies brakes when it is at point A. We already have the idea that whenever brake is applied, the body doesn't come to rest all of a sudden. The velocity doesn't become 0 directly. The body travels certain distance. Suppose the body comes to rest at position B. So this distance traveled by the body after brake is applied and before it comes to rest is known as the stopping distance. Let this distance be ds. Now from equation of motion, the third equation of motion, we have v square is equal to v0 square plus 2ax. Since V is equal to 0 as body comes to rest, we can write this implies that V0 square plus 2ax is equal to 0, which implies that V0 square is equal to minus 2ax or minus 2a ds. Here we are considering x as ds, the stopping distance, is equal to V0 square. This implies that ds is equal to minus V0 square by 2a. So ds is directly proportional to V0 square. If V0 increases, ds also increases. The more the velocity a body is traveling with, the more will be its stopping distance. The next topic we are left with is relative velocity. So for this, let us consider the motion of a body first. Suppose this body starts from this position, it comes to certain distance here. Let us say initially it was at a at 0 and it has traveled with a velocity va in time t in this direction. So what will be the total distance covered by the body in time t? Xat will be equal to the initial distance it was there, xa0, plus the distance it covers when its velocity was va. The distance it covers when the velocity was va and the time was t is given by vat. So xa at t is equal to xa0 plus vat. Similarly, for a body B, we can write xb at t is equal to xb0 plus vbt. So the displacement from object A to object B is given by xba at t is equal to xb at t minus xa at t. This is equal to xb0 plus vvt minus xa0 plus vat in the brackets, which is equal to xb0 plus vvt minus xa0 minus vat. Now we'll be writing the velocity and time terms together and the distance terms together, which is equal to xb is 0, which is equal to xb at 0 minus xa at 0 plus vbt minus vat. Now we can again rearrange it as xb at 0 minus xa at 0 plus vb minus va into t. From equation 1 we can come to a conclusion that as seen from object A, object B has a velocity Vb minus Va because the displacement from A to B changes steadily by the amount Vb minus Va in each unit of time. Velocity of B relative to A is given by Vba is equal to Vb minus Va. This is velocity of B relative to A, and the velocity of A relative to B, Vab, can be written as Va minus Bb. This is nothing but minus of Vb minus Va, which is equal to minus Vba. Now let us discuss certain special cases related to it. The first is if Va is equal to Vb, this implies that Va minus Vb is equal to 0. So equation 1 can be written as xba at t is equal to xb at 0 minus xa at 0. The two objects stay a constant distance apart, as is evident from equation number 2. So we can draw the xt graph for these two bodies as this. This is for body B, this is for body A. As you can see here, these are two parallel lines and the distance between these two shall always be a constant. The second special case is if Va is greater than Vv, this implies that Vb minus Va is negative. If Vb is 20 km per hour, let us say, and Va is 40 km per hour, let us say, then Vb minus Va is equal to minus 20 km per hour. Hence we can deduce that Vb minus Va is negative. In this case, one graph is steeper than the other. So we can draw the graph as this: x t. Steep graph for 1, for A it is steep, and for B it is given by this. The third special case is VA and VB have opposite signs, that is, one is positive, the other is negative. So the graph is given by this is x, this is t. Since one of the bodies has negative velocity, we can extend it down further. This will be the velocity of one body. Now this will be the graph for one body, and this will be the graph for another body. So that's all for today. Thank you.